Okay, section 4.3 is on separable equations. Separable differential equations. Okay, separable differential equations can be written in the form dy over g of y is equal to f of x dx. Okay, so we can separate both sides of the differential equation so all the y's are on one side and all the x's are on the other side. So let's look at an example here. Solve the differential equation y prime equals x squared minus 4 times 3y plus 2. Okay. So I want to write this as dy dx. Okay, put that in that notation is equal to x squared minus 4 times 3y plus 2. Now I'm going to want to multiply both sides by dx and divide by 3y plus 2. So let's just multiply both sides by dx first. I don't want to skip too many steps at the very beginning of us working with these things. So this becomes dy equals x squared minus 4 times 3y plus 2 dx. Now let's divide by the function of y here, 3y plus 2. So 3y plus 2 divide by 3y plus 2. And we have separated one side of the equation to involve only y's, and the other side of the equation to involve only x's. Okay. Okay, so now what do we want to do? Well, we want to integrate. So we're going to integrate, okay, both sides of the equation. Okay, so I'm going to do a u sub on this side here. I'm going to say u is equal to 3y plus 2. du is equal to 3 dy. Okay. So du over 3 is equal to dy. Okay, so let's do the u substitution. So this is 1 over u du over 3. Okay, so this is 1/3 natural log of u. Okay, But what was u? U was 3y plus 2. So this is 1/3 natural log of 3y plus 2. Okay, that's the left side done. Okay. So now we want to figure out, well, what is this equal to? It's equal to the right side. So let's integrate the right side. This one's a little bit easier. Okay, the integral of the right side is going to be x cubed over 3 minus 4x plus c. Okay. Let's bring that down. This is, I'm going to put a 1/3 here. 1/3 x cubed minus 4x plus c. Okay. Okay, I'm going to multiply both sides by 3 just to get rid of that fraction. Okay, so multiply both sides by 3. And I'm going to get the natural log of 3y plus 2 is equal to x cubed minus 12x plus 3c. Okay, but 3c is just c. It's just a constant. We could say that this is 3 times c1, and we could say, well, 3 times c1, isn't that just a c2? Isn't that just another constant? Okay, so I'm gonna call this a constant, c. Okay, so we'll just call this c2. Okay, so this is the natural log of 3y plus 2 is equal to x cubed minus 12x plus c2. Okay, now I'd like to get rid of that natural log. So I'm gonna make this base e on both sides. Okay, we try to get rid of that natural log. Okay. So now we're gonna cancel. Okay. I'm left with the absolute value, okay, of 3y plus 2 is equal to e to the x cubed minus 12x plus c2. Okay. But I can now remove the absolute value bars. I can remove these. Since e is a positive value, since e is a positive value, then even if the exponent is negative, it's not going to be a negative number. Okay, so I can remove them because e to any power is positive. Doesn't matter what the power is. So I can remove these now, and I get e to the x cubed minus 12x plus c2. Now, I'm going to do a little bit of algebraic manipulation here on e using the power of exponents, or sorry, the property of exponents, property of powers. So would you agree that e to the x cubed minus 12x times e to the c2, isn't that the same thing as what I have above, where I'm adding c2, right? When I have a common base, don't I just add the exponents together when I multiply? So what I'm going to call this guy, e to the C2, is I'm going to call him C3. Okay, not to get confused with C3PO. I'm sorry, I'm a big Star Wars fan, so I had to throw that one in there. But e to the C2 is equal to now C3 because it's just a constant. Okay, it's just a constant. So we have 3y plus 2 is equal to, this guy's a constant, C3, times C3, I'm going to put that in front, times e to the x cubed minus 12x. I'm getting close to being done here. Because this is the last constant that we're going to talk about in the problem, I'm going to let C3 equal just C. Okay, I'm just going to call it a generic C. Okay, we're going to let this now equal to just the generic C because we're not going to manipulate the constant anymore. It's gonna stay in front of the E from here on out. Okay, so this is 3y plus 2 is equal to C e to the x cubed minus 12x. And so now I'm going to subtract 2 from both sides. I'm going to get 3y plus 2, or sorry, 3y now. This cancels out. 3y is equal to C e to the x cubed minus 12x minus 2. And then I'm going to divide both sides of the equation by 3. And I'm just going to leave this as y equals C e to the x cubed minus 12x minus 2 all over 3. Now, if you really wanted to, you could split that 3 up and then create a C4. I don't really feel that's necessary. We solved for y on the left side. I'm just going to leave it in this form. You could break it up under that common denominator of 3 if you really want to. Okay, but it is solved. It is solved in this form. And so this is the general solution to the differential equation y prime is equal to x squared minus 4 times 3y plus 2. Okay, so that's the general solution. If I wanted a particular solution, I would just need a point. One point from my solution to give me a value. Because it is a first order differential equation, I would just need one point to one initial value or one initial condition or one point on the solution curve, and then I would be able to lock down what that general solution, what that particular solution would be. This is, however, a general solution because it contains my constant. Right? Okay, let's do another one of these. Okay, number 2, solve the initial value problem. Yep, we're gonna do it. Okay, solve the initial value problem. Okay, y prime is equal to 2x plus 3 times y squared minus 4 okay, uh, given y of 0 is equal to -1. Okay, so very similar to what we did before, but now we have an initial value. Okay, so we can solve for the particular solution. So I'm going to get dy dx is equal to 2x plus 3 times y squared minus 4. Okay. Okay, so let's look at this guy here. So let's split this up. Let's separate it. So dy over y squared minus 4 is equal to 2x plus 3 times dx. Okay, let's integrate both sides. This becomes dy over y squared minus 4. Now that is factorable. That's y minus 2 times y plus 2. And that is equal to 2 integral of 2x plus 3 dx. Let's work on the left side first. So this is a partial fraction decomposition. So we're going to say that 1 over y minus 2 times y plus 2 is equal to a over y minus 2 plus b over y plus 2. Let's solve the PFD here, okay, the partial fraction. Okay, multiplying through, we're going to get 1 is equal to a times y plus 2 plus b times y minus 2. Let y equal -2. Okay. And we get okay, 1 is equal to -4b when I plug that in. I'm trying not to skip steps here. 1 is equal to a times -2 plus 2 plus b times -2 minus 2. Okay, and so this goes to 0. And then we have 1 is equal to -4b divided by -4. B is equal to -1/4. Okay, what about A? Let's try to solve for A. Let A equal, or sorry, not A, let Y equal 2. And let's let Y equal 2. So if Y is equal to 2, then B goes away and we're just left with A. So 1 is equal to A times 2 plus 2 plus B times 2 minus 2. So this goes to 0. And let the 1 is equal to 4A, divide by 4. And so A is equal to positive 1. Okay. So now we're going to plug this back in, okay, and say, okay, this is going to be the integral of 1 over y minus 2 times y plus 2. Okay, that is going to be a over y minus 2 plus b over y plus 2. Okay, but what is A? A was 1/4, right? Okay, so this is 1 over 4 times y minus 2, and then minus 1 over 4 times y plus 2, because b was negative 1/4 there. And that's all going to be dy. Okay? That's on the left side there. Okay, this is still equal to the integral of 2x plus 3 on the right side, dx. Okay, all we did was the partial fraction. Okay, so a lot of work involved in this one. Okay, hopefully things start getting a little easier here. Okay, let's break this up into two integrals. I'm gonna pull out the 1/4 at the same time. 1/4, this is going to be 1 over y minus 2 dy minus 1/4 times 1 over y plus 2 dy equals the integral of 2x plus 3 dx. Okay, I'm going to do a u sub on the first one here. So u is equal to y minus 2. Du is equal to dy. So this is going to become 1/4 times the integral of 1 over u du. Okay, well, what's the integral of 1 over u? What's the integral of 1 over u?
ln.
Yeah, ln.
Those might be to say like we need to be just talk about it. Which gives me the
Thank you, Machiavelli, and thank you, Ishan. Yeah, this is just ln of u. Okay. And then, well, what was u? U was y minus 2. So this is going to be 1/4 times the natural log of y minus 2. Okay, minus, can everybody see by the same logic what's going to happen here with y plus 2? Right? Can you see that the constant -2 kind of dropped out when I did the u sub? I mean, I'll do the u sub again. But I could basically say by generality or without loss of generality, these two are going to end up being of the same form. But y plus 2 du is equal to dy, where you get negative 1/4 times the integral of 1 over u du. This is going to be minus 1/4 natural log of u. Again, same thing. And then this is just 1/4 times the natural log of y plus 2. Okay, on the right side, we can now do the right side. Let's just integrate that. That's an easy integration. That's just x squared plus 3x plus c. Okay, let's multiply through by 4. Okay, so multiply everything through by 4. And we get natural log of y minus 2 minus natural log of y plus 2 is equal to 4x squared plus 12x plus 4c. Okay. But again, for C, I'll call this a C1 here. For C1 is just C2. Okay, I can use the properties of natural logs to say this is the natural log of the absolute value of y minus 2 over y plus 2 is equal to 4x squared plus 12x plus C2. Let's let everything be an exponent to a base of e. Get rid of the natural log. We're going to get the absolute value of y minus 2 over y plus 2 is then equal to, okay, this is going to be e to the 4x squared plus 12x times e to the C2. This guy here is going to equal C3. I can plug him in front. Y minus 2 over y plus 2 is equal to C3, e to the 4x squared plus 12x. Okay, we can remove those absolute value bars because we have a base of e. Okay, I could have done that in the previous step as well. Okay, and so I'm just going to let C3 be a generic C. Okay, or we could actually, this is an initial value problem, so we can solve for C3. We could figure out what that C3 is. Okay, so the initial value was that when y is 0, or sorry, when x is 0, y is -1, right? So let's plug these values in for x and y and solve for C3. This is our general solution. Okay, but we want a particular solution because we're given an initial value problem. We have -1 minus 2 over -1 plus 2 is equal to C3 e to the 4 times 0 squared plus 12 times 0. Okay, nice. Okay, this is going to become -3 over 1 is equal to C3. This is e to the 0 plus 0, which is e to the 0. This is -3 is equal to C3 times e to the 0. That's just 1. So that tells me that C3 had to be equal to -3. So my solved state, okay, y minus 2 over y plus 2 is equal to -3 e to the 4x squared plus 12x. Okay. Okay. We've gotten rid of the differentials. We have something just in terms of y at this point. So we could stop here if we really wanted to. If it bothers you that it's not in terms of, we could stop here. If it bothers you that it's not in terms of y, you can put this in terms of y. We could just multiply both sides by y plus 2 is -3. But you could stop here if you really wanted to. You would get full credit on an exam if you stopped at this point. Okay, we evaluated the constant. It's no longer a function that involves any differentials, no y prime or y double prime. Okay, this is fine. This form is fine, but if it messes with your mojo, that it's not, one y isolated for y, we can algebraically manipulate this. It just gets a little bit messier in that we're going to multiply by y plus 2. Then we're going to have to distribute and collect like terms. So y minus 2 is equal to y times -3, write it like this, -3y, e to the 4x squared plus 12x, okay, minus 6 e to the 4x squared plus 12x. Okay, toss this guy over here, toss this guy over here. We have y plus 3y e to the 4x squared plus 12x equals 2 minus 6 e to the 4x squared plus 12x. Now let's factor out a y. Y times 1 plus 3 e to the 4x squared plus 12x equals 2 minus 6 e to the 4x squared plus 12x. Divide both sides by 1 plus 3 e to the 4x squared plus 12x plus 3 e to the 4x squared plus 12x. And I think we're pretty much done at this point. So y would be equal to 2 minus 6 e to the 4x squared plus 12x all over 1 plus 3 e to the 4x squared plus 12x. Okay. And that is 4.3.